Here is the last of our operations. We've talked about adding and subtracting, we've talked about multiplying, and now we need to talk about dividing. But before we can talk about dividing, we have to talk about something called a complex conjugate. So here's what a complex conjugate is. Complex conjugates are complex numbers that have real and imaginary parts that are the same, but the operation in between them is different. So here's an example of that. If you take a look at my expressions here, I'm claiming that these are complex conjugates. The numbers are the same, right? I have a 3 in the real number spot. That's what we call the A position. And I have a 2I in the imaginary position. That's BI, right? But I have a plus in front of one of them and a minus in front of the other, okay? And so why do we care? Why are we we have a special name for these, and what are we going to do with them? Well, they have a very special property, complex conjugates. Here's what happens. If I take these complex conjugates, 3 plus 2i and 3 minus 2i, and I multiply them together, watch what happens, okay? So there's i's in both expressions, and I'm going to multiply them together. Well, 3 times 3 gives me 9. Okay, 3 times negative 2i, negative 6i. 2 times 3, 2i times 3 is positive 6i. And 2i times negative 2i is negative 4i squared. So let's simplify just like we did when we were doing the multiplying video. Okay, so negative 6i plus 6i, well, that's negative 6 plus 6 is 0. These two values cancel each other out. Okay, and then remember, I squared is the same thing as negative 1, so this is really saying 9 minus 4 times negative 1. Well, negative 4 times negative 1 is positive 4. So this says 9 plus 4, and that's 13. So if you notice, what happened is I took an expression, okay, or a couple of expressions that were complex numbers, and I multiplied them together, and at the end, no more complex number, no more I is involved. And that's really important, because if we ever want to do a problem where I goes away, we need I to go away. If we multiply an expression like 3 plus 2i by its complex conjugate, my result will always be a real number, meaning no more I in the problem. And that's going to be really important when we divide, because if you take a look at our dividing problems, in fractions, we are always going to want the denominator to be a real number, which means I cannot be in the bottom of the fraction. Okay, so we're going to look at two different problems where we need to get I out of the bottom. And if you remember back to radicals, when we had problems that had, like, for example, the square root of 2 in the bottom of the fraction, right? Like, say, for example, I had a problem that looked like this. We also can't have radicals in the bottom of the fraction because they are not nice whole numbers. We like there to be nice integer values in the bottom of the fraction. So in this case, the square root of 2 is bad, and the way we fixed that, we called it rationalizing the denominator. And we fixed that, we said if I multiply the square root of 2 by itself, right, and we fix this, we say square root of 2 times the square root of 2, well, that fixes the bottom, and then the top changes, right, by the square root of 2. And we say this is the good form. We have a nice value in the bottom of the fraction, this 2, right? So when I'm looking at this, remember the square root of, or I is really a square root. It's kind of like this. We're kind of saying I is the square root of negative 1. So if I want to get rid of I can just multiply by I. Watch what happens, okay? When I multiply the bottom of this by I, that means just like our radical situation, I need to multiply the top by I, okay? Here's what happens. The bottom becomes 3. Well, I times I is I squared, okay? The top, I'm going to take this and distribute it in. So here's what happens. 9 times I is 9i. 12i times this I is 12i squared. Okay? So I kind of distributed the I into both of the parts on the top. So now I need to take this and I need to simplify it. So remember, I squared is negative 1. We saw that in the cycles of I. We saw that when we multiplied, and we saw that when we were dealing with simplifying exponents. So I'm actually going to say 9i. This is really saying 12 times negative 1. Well, that would be minus 12. It's all over, well, 3 times negative 1 would be negative 3. Okay, so if you notice what happened here, the bottom of my fraction had an I in it, and now it doesn't. Just the same thing that happened up here. I had a square root of 2. I didn't like it, so I did something, and my result does not have a square root of 2 anymore. That's what we're trying to accomplish. So I've accomplished what I tried to do. I'm going to do a little extra adjustment, which you'll usually see. Usually the negative does not sit in the bottom of the fraction, so that's something I'm going to fix. Okay. The other thing that usually happens is the top of the fraction has a complex number, and if you notice how all of my complex numbers are written, it's always whole number, plus imaginary number. And if you take a look over here again, whole number plus imaginary number. And I'm kind of backwards here with that. So I want to switch these. So watch what's going to happen. I'm going to take this -3 and I'm going to move it to the top, right? So if I did something like -1/2 on the top or 1/-2 on the bottom, they're the same thing. I'm just kind of like where I'm placing the negative. So I'm going to pull the negative off of here and I'm going to give it to the top, right? So it's going to look like this instead. I'm going to say the negative on top, okay, and I'm going to get rid of that little one on the bottom, right? So I just moved where it was. We usually like to keep the bottom of the fraction a nice number. So here's what's going to end up happening. Negative times 9i is -9i, and I want that to be second, okay? And then negative times -12 is +12, okay? So I just kind of switch their spots, and this is kind of more of the standard form way of seeing the problem. The top says a plus bi, the bottom doesn't have a negative, right? That's little details. As long as you're really comfortable with what we did at the top here, which was multiplying the top and the bottom by I so that I goes away, that's the main idea of the problem. Okay, so we need to do this on a second problem. But here's the catch, okay? In this second case, I don't have just an imaginary number like I did in the first case, right? Letter A, it's just 3i. There's no like add or subtract on the bottom of this fraction. When I come over to the second one, I have a binomial now. If I tried to multiply by I, let me just show you what happens. If I multiply the bottom by I, just like I did over here to try to make that happen, watch what happens. I times I, or 4i, is the -4i squared. But then this I is going to show up when I do I times 1, right? So I'm going to fix this one. That's going to turn into +4, but I didn't fix my big problem. My big problem was that I had I in the bottom of the fraction, and when I simplify this, I'm going to get I plus 4. And I'm still going to have I in the bottom of my fraction, right? So when I have a binomial, when I'm dealing with a complex number, instead of just a regular imaginary number, these complex numbers, I can't just multiply by I. So I have a different situation when there's a complex number than with an imaginary number. So here's what we got to do here. And I have it written up top for you, okay? If I have a binomial, which means I'm dealing with a complex number, I'm not going to multiply just by I. I'm going to multiply by the complex conjugate of the denominator. Okay, so if you remember what we said about complex conjugates, okay, we said 3 plus 2i, its complex conjugate is the same thing but with a minus sign. So if I'm looking at what I have on the bottom, 1 minus 4i, its complex conjugate is going to be the same thing but with a plus sign. Right? So the same expression, but we switch the signs. Okay, I'm going to multiply that on the top and the bottom. So I'm kind of doing the same thing that I was here. I'm multiplying by something to change the bottom of the fraction into a real number. But in this case, what I multiply by is different. Here it's the complex conjugate. In these ones, I can just use I. Okay, so let's finish this problem. And see what we end up with. So the bottom of the fraction is going to be one of those FOIL problems again. 1 times 1, okay, is 1. 1 times 4i is 4i. -4i times 1 is -4i. And -4i times +4i is -16i squared. Okay, so that's what the bottom FOIL multiplies into. And then I can do the same thing with the top. Becomes 2 plus 8i. Okay, let me fix my I here and make it look like an I. Okay, so I did 2 plus 8i. Now I'm going to take the 3i and multiply it in. 3i plus, and again that's 3i times 4i, that's 12i squared. Okay, and so now I need to just simplify these expressions. So the top, it looks like 11i. Okay, 2 plus 11i. And then remember, I squared is -1, so this really says minus 12. 12 times -1, minus 12. Okay, the bottom, I get that canceling happening, right? So 4i and -4i go away. And remember, this is also -1, so here's what it's going to look like. I'm going to say 1, okay, and this was -16 times -1 would be +16. Okay, so the bottom is going to switch up as well. So let's do one final combine. This now looks like 2 minus 12 is -10 plus 11i all over 17. Okay, And that looks like my good standard form. Okay, I go a plus bi on the top. There's no negatives or anything funny on the bottom, and that's a good uh, result. Okay, that's what we're trying to do. We're trying to get the negatives and the square roots and anything funny out of the denominator. In both of these problems, that is done.